experiment, that is characterize the temperature sensor thermocouple. When you go to the experiment, you will find aim, pretest, theory and procedure. Afterwards, go to simulator and click on to the simulator. The experimental setup will look like this. You have to select which type of thermocouple you want to test. For example, I have selected J-type thermocouple. Now in case of a thermocouple, the important thing is the cold junction compensation method, wherein you need to know where is the cold junction temperature and where is the compensation. For example, I have kept this reference temperature or cold junction at room temperature, and currently the room temperature is 20 degrees Celsius. That means hot junction will be exposed to the temperature which we will get from this value, and the cold junction is at 20 degrees. You have to calculate the millivolt generated by thermocouple using standard charts. The link is given to you, and then based on that put the value to enter the value. So I'll get the temperature 139 degrees Celsius. So this thermocouple is exposed to 139 degrees Celsius as hot junction temperature, and the cold junction temperature is 20 degrees Celsius. So the millivolt generated by the junction would be 6.385, and if you submit this, the reading is correct. Go to next, check next one, that is 122 degrees. 122 degrees is the exposure of the hot junction. Cold junction is still at 20 degrees Celsius. So the answer is 5.451, and then we'll enter this, we'll submit this, this is correct. Then we go to the next is 108 degrees Celsius. Now this hot junction is exposed to 108 degrees Celsius. We need to find out what will be the temperature, millivolt, which is 4.686, and if you submit this, you will find that the answer is correct, and because of that level 2 is now active. You can go to level 2, or you can plot the graph. Once you plot the graph, you will find that it's straight line, but please do not misunderstand, as this is a simulator based on standard equations, the graph will be quite linear. In reality, there would be a change. Now you can go to level 2 and expose this thermocouple to the dynamic characteristic. For example, if I select the bare element, the time constant has come to be 8 seconds. Then if you connect the sheet to that, and the sheet is with SS304 1 millimeter, you will find the time constant has gone up to 10.96 seconds. Now if you add thermowell to this, and the material of the thermowell is SS304, thickness is 1 millimeter, and the filling material is MgO powder, you will find the time constant is 16.08. Such a huge time constant you will experience. All your calculations can be seen in this window, wherein whatever you have done, whatever you have selected can be seen from here. You can plot the graph, and you can find out how the dynamic response of the thermocouple will look like.